So in the previous video, we got our array of structs in an ordered fashion. So now we can go and actually look for items in there more efficiently. And so an efficient, or at least more efficient than a brute force of checking every single item in an array, there is what's called a binary search. And so the binary search is basically you take your array and you're searching half of it and you're seeing, is the item I'm looking for where I'm at? If it is, you're done. If it's greater than, then I can cut my list in half and I could say, okay, it's either in, if it's less than, then if what I'm looking for is less than where I'm currently at, then it's in the beginning half of the array. If it's greater than, then it's in the top half of the array. And then you could cut that in half again, and you could do the same thing, and you could keep paring it down so that you eventually have a smaller thing. And so you're only ever searching for half of the array at a time, and it speeds up the process. For our little 5-element array, it really doesn't matter much. But again, if you're looking at 5,000 elements, then you're going from having to search 5,000 elements to searching 2,500 to searching 1,250 to, right? So each time you're cutting it in half, you're reducing how many items you're going to have to actually search to find the item that you want. So to get this started, we're going to need a couple variables. So let's go and make this work in CLion. So first thing we're going to need to do is we're going to need to create a function. So we're going to create a void. We could return. We'll return the index of where we're at, and we're going to call this binary bin search. And we're going to pass it the dragon array and the count. And we also need to pass it the name that we're looking for. So we'll put string and name. And then I'm going to copy this. We're going to go to our implementation file, and we're going to just come down here and put it in, paste it. And so this is going to be the start of our function that we're going to be making. And so the first thing we need to do is we're going to need a couple variables called start. We'll have that be 0, and end. That's going to equal count minus 1, because that is going to be the range of what we're going to be looking for a value, right? Is going from 0 to the end. And we're also going to need to know mid, which is going to be, and we'll calculate that in a second. So we're going to do a while start is less than or equal to end. That's going to be how often we're going to be doing this. And we're going to say if the dragon sub mid, but we need to know what mid is, right? So mid is going to be start plus end divided by 2. That's how we're going to find out the middle section. So basically we're taking our array and cutting it in half. And so d sub mid, and we want to check to see if that name equals what we're looking for. And you notice that I have name in here twice, right? But it's okay because this is a member of this struct, so it might have the same name. They might both be names, but the system knows the difference between the two of them. And so if we found it right off the bat, then hey, look at that. We did it. We could return our mid, right? That's going to tell us the location of where our name's at. If not, we could say if else if the name is less than the dragon mid subname, or then we want to change our values of change our end, right? So that means that the name is, if it's going to be found, it's going to be found in from 0 to mid. So we now we're going to make end equal mid minus 1, because we know it's not mid because we just checked mid. And else, and this else is against this if, right? If it's not, if the name we're looking for is not less than the name, then the way it's going to find it is in the top half of the array. So then we need to change our start location. So start is going to equal mid plus 1, because we know it's not mid because we checked that up here. And let's open this up so we could read the whole thing in one fell swoop. Just so we could see what we've done, right? What this is doing is it's going through and it's searching for the item that we wanted, checking to see, is it in the, did we find it off the bat with the mid? If we didn't, is it in the first half? If it is, then our end is going to be our mid minus 1, because it's the first part of the array. And if it's not, it's going to be in the mid plus, the start is going to change to mid plus 1, because it's the end of the array. And then we need to have a thing in here at the bottom. If we get all the way here to the bottom and we've gone through all of the options, we need to return minus 1, saying that it didn't find the location, right? So when we call this, we're going to say if, and we'll call, or we'll set a value. We'll say index, int index equals, and we'll do bin search, and then we need to send it the dragons and the count, which is 5, and the name we're looking for. So we're going to look for meat lug, and I might have already used index, so we'll call it idx. And so then we can say if idx is greater than -1, then we could say cout, we found your dragon at index, and we could put the index. And then else, your dragon was not found. Oh, and before this starts, I'm going to come over here into our destructor, and I'm just going to comment this out just because we don't need to have that many printouts. It makes it a little harder to read. So I'm going to compile this again, and we'll open it up and blow it up so we can see. So this was the out of ordered. We searched by ourselves and found index of equal to 3. And then this is the ordered array. And then we did a search and we found it at index 1. So there you go. We have our binary search. So I hope you enjoyed this video, and I will see you in the next one.